This topic covers the concepts of workspaces. The learning objectives for this topic are as follows: describing the function of workspaces, creating a workspace and adding models to it, and explaining concurrent model development. Our first section discusses what is a workspace within the configurator model's work area. This diagram shows the overall configurator lifecycle. In the Work Area Overview and Integration by Snapshots lesson, you learned how the lifecycle of a configurator model progresses from the initial definition of a product item to the release of the configurator model in a workspace. After the workspace is released, there are likely to be ongoing changes to that model in the Product Information Management work area, or to the supplemental structure, rules, and UIs in the configurator model's work area. These changes typically follow this following cycle: refreshing the items that have changes within Product Information Management, adding the items to a workspace in the configurator model's work area, make additional changes required to the supplemental structure, rules, and UIs, and releasing the workspace. This slide shows the workspace in the configurator modeling process. In the Work Area Overview and Integration by Snapshots lesson, we were introduced to the workspace, which is where you develop drafts of configurator models in the configurator model's work area. Workspaces are the focus of this lesson. You can edit a configurator model only by adding a released model as a draft to the workspace. A released model, after import, has the version number 0. In the workspace, you can edit the model draft and add a supplemental structure, rules, and user interfaces, and release a new version of the model by releasing the workspace. Our next section discusses what a workspace is and how models and snapshots can be added to that workspace. Workspaces enable you to develop new versions of configurator models in an incremental manner and control the release into production. The configurator workspace allows draft models to be edited together and tested as a group without affecting the definition of production data. When ready, the drafts in the configurator workspace are released as a group with all versions inheriting the same effectivity date. Consider the example of working on an online tax return. You start the return, add the income and deductions information, review your return, and then submit it. A similar process takes place in a workspace. You create a new workspace and add all the models that you want to make changes to, or the models that are affected by a snapshot update. The runtime behavior of these models can be tested as a set or as a group. After the testing is complete, the workspace is released, which means that all the changes to the models or the changes to the snapshots in the workspace become effective as of the effective start date of the workspace. Using workspaces allow for concurrent draft development that is driven by the effective start date of the workspace. Concurrent draft development is covered later in this topic, and the concept becomes clear when you start learning about versioning and release. The workspace respects the item and component's effectivity that is defined in PIM, congruent to the workspace effective start date. As an example, you may have a workspace with an effective start date of June 1st that contains a snapshot of an item that is effective on June 15th. On release of the workspace, the item would not be available for selection until June 15th. This screenshot illustrates that when you create a workspace, you enter values for its attributes, which are the name, description, and effective start date. After you have entered the attributes, you add models and related components as participants of the workspace. A workspace begins with the default status of in development. This screenshot shows how you can add the following to a workspace as participants. Those include models, item snapshots, item class snapshots, and value set snapshots. Here's some examples of scenarios of when you add each of the participant type. A value set. Some items in a model have a transactional item attribute, or TIA, named color. It is an attribute which lists and uses the value set name external colors. When a new color gets added to the value set, you would refresh the value set snapshot and add that snapshot to a workspace that's being shown to the end user when an item with the TIA color is being configured. Item class. Items inherit classes, so if a new TIA is added to the item class snapshot can be refreshed and added to a workspace to verify that the new TIA is being displayed in the runtime UI. An item. If an option class has a new component added, you can refresh its snapshot and add that snapshot to the workspace to verify that the new item component is displayed in the runtime UI. And model. To be able to test changes to a value set, an item class, or an item snapshots with items that correspond to the respective changes to the workspace, so that you can test those changes in the context of a model. Even when you do not have any such changes, if you want to add a new rule to an existing model, or edit an existing UI, or create a new UI, you can add a model lead with making the changes. This screen shows how you can lock configurator models to prevent another user from making changes that would conflict with the changes that you are currently making to the same model. Here are some factors. Models added to a workspace are the only participants that can be edited. Before editing a model, when you add model to a workspace, it is locked by default. And when it will be unlocked by clicking the unlock button. When a model is unlocked, it is enabled, and it can be used to lock the model for editing. The next section discusses effective start date and snapshot effectivity work together. Additionally, it discusses concurrent model development and how you can be sure that work done on a model in a different workspace is always updated into a workspace with the same model. The screenshot here depicts a scenario in which you have set the effect at some future date, but the changes in a snapshot in the workspace are already effective. The model shown in this example is a tablet computer, which has a new option class added for color selections. The option class is effective as of today, whereas the workspace was created with an effective start date sometime next week. When they're refreshed and added to the workspace, the following warning is displayed. One or more participants have changes that take effect before the current date and time. This will become effective immediately upon release. Earlier in this lesson, we learned about the congruence of workspace effective start date and that the workspace respects the item and component effectivity defined in the product information management work area, which is congruent to the workspace's effective start date. Here are some examples. The workspace effectivity start date is June 1st. A component snapshot in its effective is on June 15. On release of this workspace, which means on or before June, not available for selection until June 15th. In the same workspace, with an effective start date of June 1st, contains a component snapshot that is effective on May 5th. Release of the workspace, it is effective immediately, and the component is available for selection immediately. To reiterate this concept, the workspace effective start date works in tandem with snapshot effectivity. Snapshot effectivity could even end up altering the workspace effective start date. The driving factor here is to keep the item that is used in the configuration in sync with the item definition, which is defined in the product information management work area. Earlier in the lesson, there was a reference of model drafts. Concurrent development is defined as two or more PCMs working on model drafts of the same model in different workspaces, each workspace having its own effective start date. This diagram depicts how this works. When Classic Sedan and the model that is referenced by it, engine assembly, are imported, the import by default adds the two models to the workspace and releases the workspace immediately. Version 0 of each model is created at the time. What this means is that the product hub equivalent of these models are approved for the first time. Any further changes to the model must be done within the workspaces. Workspace WS1 is created by one PCM T0 on the example timeline to create a step-by-step UI for the sedan model so that order management users, when they configure the sedan, can use the step-by-step UI. After a few days, marked at T1, WS PCM to add more rules and enhance the step-by-step UI. The changes to the model in WS2 can occur rather concurrently. When WS1 is released, marked at T2, marked at T3, the changes to the model in WS1, that is, the step-by-step UI that was created, will be visible in WS2 after the release of WS1 becomes the baseline version for the models in WS2 has been updated. Work done in WS1 on the same model need not be manually repeated in WS2 to keep up with the changes. The example that would, but this concept applies to any work that is done on the model in WS1, be rule changes or changes to supplemental structure. In this included practice, we'll create a